word. Okay. I am not sure whether you really remember what we discussed. Okay. But let me recap certain things so that it will be easy for you guys. I'm sure you might have forgot about the subject. Okay. Let me go share my screen. Where am I? Here. Okay, friends. So we have data. We are collecting data. Onto this data, we are trying to apply different statistical methods. What is that we are trying to apply? Different statistical methods we are trying to apply. Okay. And these statistical methods are going to operate on sample data, population data. Now, statistical methods are divided into two types. What are they? Do you guys remember? Anyone can remember? Can you type that in the group chat? Statistical methods are two types. I know you guys forgot. Ah, right. Good. So, two types. One is descriptive. Another one is inferential. Right? Clear? Good. As the name suggests, descriptive statistics will be trying to explain what the data is all about. Whereas inferential statistics is mainly focused on, given the sample data, how can I identify or how can I predict my population parameters? That is what it focuses on. So the descriptive statistics basically revolves around three dimensions. This revolves around three dimensions. What is the first dimension? The first dimension is central tendency. It focuses on the central tendency of the data. What is the second dimension? Dispersion of the data. Third one, shape of the data. Okay, so these three dimensions which it focuses, and that's where you will be able to describe the certain characteristics of the data. Thereby, you can understand the data in a much better way, and you can apply your understanding onto the business decisions to make some kind of a conclusion on your business. Okay. Now, inferential statistics mainly focus on random variables. Okay. When we talk about random variables, there are two types of random variables. One is discrete random variable. Another one is continuous. Okay. So why I wanted to write it in this fashion is many people get confused with this term and they think this and this more or less the same. They are not same. I wanted to tell you that. Okay, descriptive statistics is different. Inferential statistics is different. Okay, within the inferential statistics, you need to, when we talk about the random variables, okay, we here inferential statistics is all about population. Okay, and when we talk about inferential statistics, we will be talking about random variables. Within the random variables, we will be talking about discrete and continuous. What is this random variable? That means my data is random variable, contains a lot of random variables, and we are segregating these random variables into two, discrete and continuous. Till here, any question or any doubt up to this point? Is that clear to you guys, or you are expecting some more clarification around this? I just wanted to hear from you. Please respond. Is this clear? This picture has to go and sit in your mind. Okay. Now, we also talked at very high level. We talked at very high level. Under this discrete, so why do we want to have such kind of a clarification is first that we need to think about. Suppose if the data is of type discrete, okay, if I want to understand how this particular data is behaving, okay, I need to know certain information about this discrete data. So to know that the information, how this behaves, how this particular discrete data behaves, there are certain data distributions which are already available to us. These distributions are invented by the various statisticians and mathematician scientists who invested their life into this, and they have come up with wonderful formulas which will make our life much simpler and easy. So as part of that, when we will be discussing about these are the various data distribution that we'll be focusing on. First one, as part of the discrete, Bernoulli distribution, or I can call it as Bernoulli random variable. Second one, binomial distribution. Third one, Poisson distribution. Okay. Fourth one, geometric progression. There are many like this. Similarly, when we deal with the continuous data, when we deal with the continuous random variable, there are few data distributions which we will be taking the help and trying to understand the data in much better fashion. In that, the most popular one is normal distribution. This is very, very popular, normal distribution. Then uniform distribution. Then you have gamma distribution. Okay. There are exponential distribution. There are many. Again, here also there are many. You may ask question, when you have so many such data distribution, how is it that I need to know all these distributions? Answer is yes and no. Yes, because if you know all these at least minimum 20-25 data distribution formulas and how the data behaves, your building up a model becomes much more accurate, and you can actually do a phenomenal job. Answer is no. If you know how to convert the data into normal distribution, especially when it comes to the continuous, when you try to convert that into the normal distribution, then you are good to go. So there are a lot of people, generally students will come and ask me like, sir, what will tell me one or two so that I can really focus only those things. I'll tell them, you please remember these three and these two. That will help you to really start the career in the data science area. And as and when you move along, you start looking into other distributions which will enhance your knowledge levels. Okay. So from that standpoint, I'm going to discuss only these five, which will make your life simpler. Is my expectation fair enough, guys? Please respond. Okay. So now question comes, why should I study these distribution? Now, for this is where we actually step into probability. Probability, that means this is 1. Value probability having value 1 means in the event, any event that is happening, 1 stands for your success and 0 stands for, I will not say failure. Okay, let us write it this as a failure. That means the experiment is actually failed. Okay. Tossing a coin. When before I toss a coin, I define my random variable as falling the head. I'm going to get a head after flipping the coin or after tossing a coin. If that value, if I associate as a success, then it is the value of probability is 1. So what it actually represents here is, in the probability, you are moving from impossible state to certainty. That means it is confirmed, okay, what is the value that it is going to happen. So from 0 to 1, you will move. 1 stands for certainty. This is going to happen. So now at what level it is going to happen? Is it 0.2, 0.3, 0.4, 0.5, 0.8, 0.9, whatever it is? So the various values will be possible. And if you know the data distribution, within the distribution, there is a mechanism for you to find out the probabilities. So when I'm talking about the probabilities, naturally that should come into your mind is histogram. Did you guys remember? This is histogram. On this side of your histogram axis, let us assume this is my x. Okay. Here there is one scale. What is the scale? This is occurrence or count, I can say. Count or occurrence. Every time, how many times this particular point is happening? 1 time, 2 times, 3 times, or whatever. So onto the other side of the scale, okay, I may be plotting the probability. The scale may be different. here and here, but the shape of the curve is going to be the same. This is called bell curve. So what happens here is the area under this bell curve, this area, whatever the area we will talk about, the area under this curve is equal to 1. Okay. Because of such property, it offers me a phenomenal capabilities to predict, to understand my data in a much better fashion. We will go and dig into these facts in detail as we move along. Okay, I'm trying to set the context for us to take you guys into data distributions. Till this point, friends, any confusion or any issue or any question? What happened? No response. You're not happy. Hello? Guys, am I audible to you, by the way? Guys, from here onwards, I wanted to be very interactive, my dear friends. Let me tell you very clearly. The reason why I wanted to be very interactive here is, from here onwards, subject will go deep into deep. Subject will go very deep. If you don't pay attention, it is something like you are listening, you are understand, you are trying to. It looks like a Sanskrit for you. If this clarity is missing, then forget about you building the mathematical modeling. Okay. It is something like we are stepping into the river. We almost crossed 1/4 of, I mean, we just got into the 1/4 from the bank. Now the river becomes deep. Okay. So pay attention what I am going to teach from now onwards. Till now, even if you don't understand anything, that's all fine. But from here onward, please pay attention. Okay. Okay. Oh. As we were discussing about the data distributions, now let us look at from a discrete random variable perspective, discrete random variable standpoint of view. The first data distribution what we look at is Bernoulli. Bernoulli distribution. Very, very useful and very, very important. And very easy. There's nothing rocket science about it. Okay. So the question comes, when do I say a data is actually a Bernoulli? What is the data? Let me reword the statement data now here. So I will write, let me write it down for you. So I call X is a discrete random variable. Okay. If and only if X takes the values 0 and 1, and the number of tries that I will do is equals to 1 with a probability P. Are you with me? Then the question comes, what is the probability? Probability is the measure of the likelihood that an event will occur. Please remember. Let me write it down so that you guys will remember this. Now we are talking a little more deep into the probabilities of it. Probability is the measure of the likelihood that an event will occur. Okay. Remember this word. Very, 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 very critical and crucial. It is all about this likelihood. Okay. Now, coming back to this side. X is a discrete random variable, or let me put it this way. There are two terms. One is experiment. I don't need to repeat this because you guys know what this experiment is. And there is another term called trial. Experiment, tossing a coin, is my experiment. Trial, the same experiment, I do it multiple times. I may toss it for one time, I may toss it for two times, I may toss it for three times. It may go on like this. It may go on like this. Bernoulli is always it represents with respect to the either success or failure. It is either success or failure. Let me write it down for you. Let me write it so that you remember. X, I'm defining X. X is a discrete random variable X becomes Bernoulli random variable X becomes Bernoulli random variable if and only if this double F is called as, this is what, if and only if, this is what it means. This is the mathematical way of writing it, right, representing the information. There are three conditions that has to be satisfied. What are those three conditions? Let me write it down. I'm just taking condition one. X takes values zero or one, no in between values. That means either success or failure. Tossing a coin, flipping a coin, failing the test case, getting a loan, hiring a person, joining into a job. These are all the examples of Bernoulli. These random variables represents your Bernoulli distribution. That means X takes the values 0 or 1. Second, number of trials equals to 1. Only one trial has been made. I can conduct the experiment multiple times, but trial is only one. And the success probability equals to P, small p. That means here is my random. I am going to get into my data model. Probability distribution model. You remember, probability distribution model is nothing but drawing something like this. X and your probability P at X is equal to whatever it is. Okay. So my x equals to 1, which is my success. The way I define my x random variable, the success criteria of my random variable is represented by 1. In such a situation, my probability is represented as P. The opposite of this is 0. What is the probability of 0? The probability of my success plus probability of my failure equals to 1. That is what it is, right? Success probability plus failure probability, that is equals to 1. This is not, if this is success probability, if I say P, and my false probability is 1 minus P. Do you agree this, guys? Any doubt here? Please respond. Any doubt? Are you with me, guys? Okay. So this probability becomes 1 minus P. Are you with me? In such a situation, for this particular Bernoulli equation, for this Bernoulli random variable, okay. Now, because we are talking about because we are talking about probability distribution, and we are talking about discrete random variables probability distribution, what will be the function is probability function is called as, it is called as PMS, probability mass function. Okay. If it is a continuous random variable, it is called as probability density function. Because it is a discrete, we will be calling this as probability mass function. So what is this probability mass function? This probability mass function will give you the distribution of the probability. How the distribution is going to be? My probability of my random variable x at a small x equals to p to the power of x multiplied by 1 minus p to the power of 1 minus x. This is the formula for calculating the probabilities for when the data is a Bernoulli. Please understand this and please remember, this has to get into your head just like that. You can't forget this. You can forget your name, but you can't forget this. Are you with me, friends? Okay. So probability of my success, that means probability of my random variable when I become successful on my random variable is nothing but p to the power of 1, because x here is 1, 1 minus p into 1 minus 1, which is nothing but p into 1 minus p to the power of 0, which is nothing but p into 1, which is nothing but p. You see here, this is right. When my x takes the value 1, my probability becomes p. Any question, my dear friends? Okay. Now probability of my x at 0, that means when my random variable is not happening, or it's a fail in this situation, my this will become 0 into 1 minus p 1 minus 0. P to the power of 0 is how much? This is 1 multiplied by 1 minus P. This is nothing but 1 minus P. This is matching. So this is the probability PMF when your data is Bernoulli. Keep this in mind, my dear friends. Random variable is the outcome of your event. Gautam? Gautam is asking a question. Okay, I just answered it. Okay, now the story is not ended here. From now onwards, you will be continuously hearing from my mouth about two important concepts. What are those important concepts? What is the expected value of X? What is the variance of X? Okay. I know the probability because in real world, you do not know the probability. If you know the probability, the story is over. Right? Why? Because I am trying to find, I may have the sample with me right now. From the sample, these are the values which are useful for your, these are the values which are calculated for population. I know the probability. I know other mean or other whatever the parameters or statistics that we can think of. From there, if I know these values, I know I can explain my population behavior completely. So you need to know what is the formula for my expected value of X. As part of the definition, it is nothing but sigma xi multiplied by your probability when X is equal to xi. Guys, do you remember these formulas? I am sure 300% you might have forgotten all these formulas. Pay attention, my dear friends. This is a beautiful subject and it needs a brain, that's all. It's not like Java, it's not like something else. You learn it and you forget it, then it won't work that way. Everybody, many students will come to me and say, sir, we want to learn data science. After 5-6 classes, they'll say, sir, I cannot learn this data science. Because unfortunately, many of the computer science students or some other students have the fear of coding. When I go to the interviews, people say, anything other than coding, I am fine. And everybody talks about management, I am too good because I handled this event, that event in the college. I say, go back to the college and study there itself. Don't come to the job. And they say, oh, you put me into testing and I'm happy to do the testing. I'm really scared of coding. I really don't understand this concept, this philosophy. And they come here and then when they get into and they'll say, oh, we want to get into data science, we want to get into the cyber security, we want to get into the cloud, big data. You don't even know the fundamentals. And you all talk about so many other things and you just like whatever you can do on this one. No. You will be a disaster when you get into these subjects, and especially the data science, artificial intelligence, and machine learning side. If you don't take pen and paper and work, forget about this subject. Coming back to you. Now, what is this sigma xi into pi? What is my xi here in this context? You have two values. One is x is equal to 0. Another one is x is equal to 1. This is my success. This is not my success. So what is the xi value? First xi value is 1. I'm talking about success. 1 multiplied by when I have the xi equals to 1, what will be my probability? My probability here is we got it as P. This is P. Since it is sigma, I have to do the same thing. I mean, I have to do this, apply the same formula for both the values. Plus, what is the second value? 0 multiplied by 1 minus P. Why 1 minus P? Because when it is 0, when xi equal to 0, the probability is 1 minus P. So, this becomes P plus 0, nothing but P, meaning expected value of x is equal to P. That means when my data x follows the Bernoulli distribution, expected value of x is nothing but probability of the success of the event. Remember, any question, please, friends? Once again, I am telling you, be with me. If you don't understand, please raise your hand and ask me, because from here onwards, subject will go deep and deep. Okay? Then, this is the first thing that you need to remember. Second one for the Bernoulli. What is the variance of x? Again, formula. 300% sure you might have forgot this formula. Variance of x is nothing but expected value of x square minus expected value of x whole square. We have derived this formula also in the class. Okay. Now, let's see this. I'm taking this term. Expected value of x square. In place of x, you have x square. So, from the definition perspective, I call this as my xi square probability of at x is equal to xi square. This I can write it as xi square, but probability at xi, because whether it is xi square or xi cube or whatever, the probability of xi, these are all same. This point also we proved earlier. Probability is not going to change. So I can write this equation like this. Okay. Now xi square. What is the x values we have? 1 and 0. So 1 square, this becomes, probability becomes 1, P. Sorry, let me remove this so that you will be in confusion. I want to remove the confusion. This is nothing but probability when x is equal to 1 plus 0 square multiplied by probability when x is equal to 0. This means 1 into P plus 0, which is nothing but P. Clear? So this value becomes P minus probability of x, expected value of x, we have just sorry, expected value of x, which we derived here, right? This is nothing but P of whole square. So I take P common, then this becomes 1 minus P. So variance of x for Bernoulli equation is this. Remember. Clear? Excuse me. Okay. So what is how do we represent your x is following Bernoulli? So there is a syntax. Remember this. I say x follows this symbol. This symbol stands for follows. When x follows Bernoulli, then there are certain parameters. This area represents your parameters. What is the parameter here? You know n, number of trials you know, right? If you know probability P, then you will be able to tell you what exactly, how exactly the x is going to behave. So you say x follows Bernoulli, the parameter is P. Okay? That means if I know P, I can calculate all other parameters. Then I have a complete understanding of my random variable x. Fair enough? So in a nutshell, what you need to remember here is expected value of x equal to P, variance of x is equal to P into 1 minus P, okay, and the probability distribution, your PMF function, nothing but P to the power of x multiplied by 1 minus P into 1 minus x. Please remember, these are the formulas for your Bernoulli distribution. Any questions, friends? Okay. So one more point here which we'll say. I wanted to bring it to your notice, okay? What is that point? When you are working on a sample, okay, if you increase the sample size, your probability, your P is going to be closer to the population P. One learning out of this note, remember, if you increase sample size, your P sample becomes closer to probability of your population. That is the catch. So more data in your sample, better accuracy you will arrive at when data is following Bernoulli. Because question will come to you, how much sample size I have to collect, whether it is 100 records or 200 records or 500 records or whatever it is. Okay, let me show you something interesting. Okay. I'm taking you guys into a software tool called Minitab. You can download it from internet. Okay, that's not a problem. Okay. In this Minitab, excuse me, I wanted to demonstrate how this Bernoulli works. Now let us assume I have an experiment of tossing a coin. So I wanted to repeat this experiment for 1,000 times. Every time there is only one train. Okay, this is my X. So I have done that experiment and I collected. I defined my X variable, random variable, as getting a head. Getting a head is my random variable X. And I did this experiment tossing a coin 1,000 times, and I collected the data whether it is a head or a tail. If it is a tail, it is 0. If it is head, it is equals to 1. Now I want to simulate the same situation here. Same data. How do I do that simulation in this tool? I go to Cal, random data, Bernoulli. Here I entered 1,000 rows. That means 1,000 experiment. I'm doing 1,000 trials. I'm doing it here, and I wanted to store it in the first C1 column. I click this, select it, automatically visible here. Event probability is something I have to specify. That means whatever the event probability I specify, system will generate the data in such a way that anything, if I say 0.6 here, any event that is occurring with a 0.6 probability, it will show that as a 1 here. It will show you. Let me run this. See here, data is generated here. How many data points I have? Close about 1,000 data points I have. Okay. Now from these out of these 1,000, okay, this is the experiment. This is the experiment which I have done it. I collected the data. Because we don't try to toss the coin for 1,000 times, I simply simulated the same scenario in Minitab, and the results are out here. Okay, so let us assume that this 1,000 is a population. For concept understanding perspective, I am telling you these 1,000 records representing your population. How many ones are here? The one, if I count all the ones, which is nothing but my average. Do you agree? Because it is only 0 and 1. That means the total number of count and the average both are same. So what I do, go to stat, base statistics, display descriptive statistics. This one, what is the statistics I'm looking at it? I'm looking at mean, sum also I'm looking at it. Okay. There are many other factors, no need to worry about that. I select that. See here, system calculated few things, few parameters here. What is my sum? Sum is 595. That means out of 1000 times tries that I made 595 times head appeared. Are you with me? What is an average? See, average is same. 0.59, 595. Because average is nothing but, excuse me guys, this 595 divided by 1000. That is nothing but your 0.595. What is my n? And this total number of trials, I did it for 1000 times. This is my sum, this is my average. So if I want to know the probability, this is the probability. Your mean is right now representing your probability. Okay. In that, let's say I am collecting only I am collecting how many things? Let's say, oh sorry. Let's say 537 records I am collecting. I am pasting it here. I am labeling this as no. This I am labeling it as X2. Now I am going to run the same thing, stat, basic statistic, descriptive, whatever it is. Even if you don't understand also, this is fine buddies, this just be with me. I just wanted to take you to the concept. See, my n is 537. Okay. And the sum is 325. My mean is going to be 0.6052. But what is the actual population mean? Population is 0.955. This is actual population. But with the sample, you are able to see it is 569 something, right? 5.6 something. See here, 0.6052. If you take more and more number of data points, the 0.6502 will be closer to this 0.59. You don't agree to my statement? Let me go and copy this information. I am copying. I can generate the what do you call more number of records here. I copied here. This I am putting it as X3. Okay. Now go stat X3 statistics, same thing. Okay. Okay. See, point this time n is 777. Mean has become 0.61, which is much on the higher side of this one. Okay, but it will converge if you take more lot of data further, so it will come down to 0.59. If you include other record, it will come down. So what it is representing is the more number of data that you collect, the data will converge towards this to accurate value of the your mean, which is nothing but a mean is nothing but a probability over here, because probability is total number of occurrence divided by the total number of elements. In this situation, in the Bernoulli, the values are going to be 0 or 1. There is no other values. So your count and your probability both are same. So mean is nothing but a probability here. Is this clear to you guys? Exactly. Gautam is saying, since it is because the data is system generated. If the 1,000 trials are really performed well, will scenario be the same? Yes. Tomorrow I will show you that part. Okay, how to do when you do the experimentation, how my probabilities are going to be, how do we simulate the same experimentation using the certain formulas in your binomial distribution. So tomorrow we will talk about binomial distribution. So this is all about your Bernoulli distribution, guys. One thing you need to remember, Bernoulli is always refers to the events in such a way where you are choosing the random variables which has binary values. Remember, Bernoulli is always about binary. What is binary? Binary means 0 or 1. That means success or failure, loan issued or not, whether the person joined in the job or not, hiring a whether a person job, and tossing a coin or not. These are all in the examples for your Bernoulli distribution. Hope I made it clear to you guys in a much more simpler way of. You won't find this kind of explanation in any textbook, my dear friends. Let me tell you very clearly. You will only see the equations. Okay, you only see that equation of probability x equal to xi is equal to x to the power of p to the power of x into 1 minus p to the power of 1 minus x. You will not find this kind of explanation anywhere else. Be assured about it. And that is where I am good at. I can tell you where this can be applicable, how to derive the meaning out of these mathematical expressions. That is the challenge. This is, even though you will go and meet the people who have done the PhDs, many people don't even able to explain the physical significance or physical representation of what these equations are. Very few, and those will become a great scientist, great data scientist. Okay, see you guys, see you tomorrow.